Hello. The question that we want to look at today is of Kenya Certificate of Secondary Education, 1996, question 12, which reads, solve the equation sine of 5 over 2 theta is equals to negative half for theta within the range 0 degrees to 180 degrees. That is 2 marks. So let's look at the solution. Well, now the question is we are handling KCSE Paper 1, 1996, question 12, and the question is sin of 5 over 2 theta is equal to negative half for theta lying between 0 degrees and 180 degrees. Between 0 degrees and 180 degrees. So the first thing that we need to note and observe is that a sine function, if drawn, it makes 1 period after 2 pi. So that then means that we are expecting a 2 pi period out of a sine function. And so for us to define what 2.5 theta will look like, we say 2.5 theta is equal to sine inverse of negative half plus 2 pi, which represents a period, 1 period, but we put k because there are multiple periods. It's a wave that moves us like ripples of water. It moves as such. So there are periods, okay, like that, that's a period, like that, like that, like that. So k here is an integer that will represent the periods that we are referring to. So if we have this, so that's one case we can have. The other case we can have, because we are dealing with quadrants here, and the limits is 0 degrees and 180 degrees. The other option we can have is that 2.5 theta can also be pi minus sine inverse of this. That's basically just this part here that we're referring to, because that's when it begins. Plus 2 pi k. K is still the integer that I referred to. Still the integer that I referred to. So we have two possibilities where we can have we can express theta. And the next thing we can see is that we can then we need to read what the sine inverse of negative 0.5 is. This we can read from our calculators. And if we do that, we see that sine inverse of 0.5 is 30. So it means sine inverse of negative 0.5 will be negative 30. So our first expression, which we draw from here, you can check the sine inverse of negative 0.5 from your calculator. And you'll agree that then here we have 2.5 theta is equal to negative 30 degrees. I want to call it, okay, let me call it negative 30 degrees plus 2 pi k plus 2 pi k. That's one. The second one is, now we pick this portion here and we say 2.5 theta will be pi minus then again we just put minus minus this. So it's pi first, but now it's minus 30 minus 30. So it becomes plus 30 degrees plus 2 pi k plus 2 pi k. So those are the possibilities, the two possibilities that we can have while expressing the values of theta. But look, we have theta, we have degrees. Theta, degrees. If I could express this in theta in pi form, then I can simplify that. So I would then ask myself, we just say, but 30 degrees is similar to saying pi over 6. That's pi over 6 because it is 30 over 180 degrees. So it will be pi over 6. It's pi over 6. So where there is 30 degrees, then I put pi over 5. So I have 2.5 theta is equal to pi plus pi over, we said it's pi over what? 6 plus 2 pi k plus 2 pi k, which will be 2.5 theta is equal to 7 over 6 pi plus 2 pi k. Yes. Now, that means I've already simplified this part. I need to use that particular notion to simplify this part because there's one here. So I should just come here and say 2.5 theta is equal to minus of pi over 6 plus 2 pi k. 2 pi k plus 2 pi k. Yes, so I have two equations that represent theta. So it means that I can then work out the value of theta, what the value of theta is in each instance. So I want to take this case here where it is, where the first case that I considered, where we said that 2.5 theta is equal to minus of pi over 6 plus 2 pi k. Plus 2 pi k. So we can, that is first. Then the second one is, that is that, or the second one is this that we already have. So it's this or this. Those are two expressions that can give us the value of theta. So up to there, then we test. We said that these are periods. So we'll start testing when k is 0, then we test when k is 1, and probably, if possible, when k is 2, depending on the limit, how we get our values. So having these two, the first question I'll ask myself is, first of all, there'll be need to make Q the subject in each case, but that I can do later. Okay, so I can just move on and do that later. So I say, I want to consider the first case. For k is equal to 0, 2.5 theta will be 7 over 6 pi plus 0, because k there is 0, so the whole element goes to 0. Now that then should imply that theta, that implies that theta is therefore 7 pi divided by 2.5 times 6. Divided by 2.5 times 6. So 7 pi divided by 2.5 times 6. 2.5 times 6, let me just work it outside. 2.5 times 6, that's 0. That's 15. So I get 15. So that will be 7 pi over 15. 7 pi over 15. That is one of our that is when we have k to be 0. But then what if we have, so that is k is 0 using this. But now what do we get when we use this? When we use this, it will be it will be 2.5 q, 2.5 theta, it will be 2.5 theta is equal to, now we are using the second one, minus pi over 6 plus 2 times pi times 0, which is 0. So it ends up to be this. That then implies that theta theta is equal to minus pi over 15. Theta is minus pi over 15. That is when we consider this for k is 0. Now for k is 1, for k is 1, for k is 1, we have the first case. If k is 1, we'll have the first case being 2 theta is equal to, no, 2.5 theta, 2.5 theta, 2.5 theta will be given by 7 over 6 pi plus 2 pi, which is 12 pi plus 7 pi, and that is 17 pi over 6. So 2.5 q is equal to that, implying that q in this case will be 17 pi over 15. 17 pi over 15. Yeah, we have that. Then the second bit is sorry, 12, 7. Oh, this is 19. 7 plus 12 is 19, not 17, 19. So I have 19. Sorry, 19. Yeah, that's for k is equal to 1 if I use this. Now, what if I use this? It will be, if I use this, it will be yeah, because now I'm using this. It will be 2.5q is equal to negative pi over 6 plus k is now is 1 plus 2 pi, which will give us, we have 6 here, so that is 12 pi plus minus, yeah, so that is 2.5 theta is equal to minus 11 pi over 6, implying that theta will be minus 11 pi minus 11 pi over 15. So that's it. So let's get our angles, having those ones now, having those points, and bearing in mind that they should lie between 0 and 180 degrees, as had already been said. So, what are the corresponding values that we have? Pi, we can already give the values as we had. So here, first, there are some that we had here, I've rubbed. I hope you have noted. But then here, what is theta here? Theta then becomes 19 times pi, where pi is 3.142 divided by 15. That gives us what? So here we can say it's approximately 19 times 3.142 all over 15. That gives us that value. And yes, that gives us that value. Then the value we add, and that should be, that is actually the value that it's going to give us is not in range, because whatever we are going to get here, it's in radians, and if we convert it into degrees, it's outside the range. So what we get that is inside the range is the value that we get that corresponds to when k was 0, when k was 0, when k was 0 for equation. So the solutions that we are going to have when k is 0 and you are using equation x is equal to, now actually theta is equal to minus pi over 15, and that gave us that if you get that, if you get this degrees and work it out, it should give you about so this one is outside the range. Sorry, when it's outside the range because it will be negative of that, and that one we had worked it out in the bit that I've just rubbed. But the one that complies is where we had 7 pi over 15. When k is 0, we had some point where 7 pi is over 15. Now, when 7 pi is over 15, then 7 times 3.142, 7 times 1.342 divided by 15, you get those radians. That radians converted into degrees should give you approximately 84 degrees. Should give you approximately 84 degrees. So that's one of our values that we say is inside 0 and 180 degrees. Remember that 1 degree is equivalent to 0.0175 radians. Yeah. So that's how you convert this to this. Okay. The other value that conforms to what we had wanted is when the solution is, we also had a situation where we said when k is 1, when k is 1, and we had this equation where we have 19 over 15, and we get these radians. Now, these radians, if you get if you get this into radians and convert it into degrees, you get the value about 132 degrees. So it means that our answer, you get the value negative 32. You get the value approximately, let me just say, approximately 132 degrees. 132 degrees. Yeah. So those are the answers to that question, and I hope you followed. One thing to note here is the fact that a sine function has periods. So those periods have to be observed, and where it begins, which is actually minus where we had that over that. So it starts from there, then the period actually starts from here. Then the period continues from there. So this is the main thing. This is the main thing that one has to remember. Once you have this in relation to the question that you have, then you can specify all possible values by alternating the points of K. Up to there, I stop and we meet in another video.